either for Gen C or Gen C Elevate. Yes, today we have another important program from Cognizant that is open only for those who are registered for Gen C and Gen C Elevate. By chance, if any of you could not register for Gen C or Gen C Elevate, if you let us know quickly, we are meeting today at 6 p.m. So we can try to add you for a different role inside Cognizant. But unless you tell, we'll not be able to know that. So if any of such things, Benaka, you can let me know by 3 p.m. today.
Okay, sir. Sure.
Yes. Yes. So let us come back to the discussion. So we are in the last module, that is module 4, which deals about second phase of your object-oriented modeling and design, where we look at the remaining two models. So if you remember, we have three models from OMD perspective. That is a class model, state model, and interaction model. Class model majorly describes about how the classes or the related objects are associated. That's what we have seen in length, both in the normal class modeling as well as advanced class modeling. Now we'll venture into the remaining two models. So briefly, the state model is about how the objects are going to interact rather with respect to the time. So when someone talks about the state model, it is majorly the state of affairs of those objects which are involved in the model given a particular time. So when it comes to the interaction model, as the name says, what type of behavior or what type of interaction that happen between or among the classes and objects is what we are going to describe. So each of these models are unique in their own perspective, and probably we can bring some thin line commonality between or among these three models, which is going to be revolving around the various classes and objects. Otherwise, each model will portray a specific kind of diagram. If you look at class model, it will give us a class diagram. State model will give us a state diagram, while interaction model will give us use case diagram, activity diagram, component diagrams, sequence diagram, and stuff like that. So there we look at how the each objects are interacting with each other, what happens when something happens inside the one of the object, how the influence is going to be with the other objects, how the flow of activities or flow of direction is available from one object to another object. All these things you can visualize from the interaction model, right? Now coming to the state model, of which is today's discussion, maybe next couple of hours we'll be working on how state model can be portrayed and how state diagrams, which are part of the state model, can be written, right? So probably by end of next week, you should be able to complete the activity which you have been working in the lab, where madam is discussing about various class model and stuff like that, because that should not again be stopped or hampering your academic schedule. So don't postpone till the last minute. Try to complete as and when you find time, because you have to do justice for both academics as well as your placement as well. At the same time, you cannot ignore the requirements of CIE, because your CIE is going to decide how your second semester SGPA or CGPA is going to be. So do not ignore that and concentrate and ensure that you complete that in time. So coming to the state modeling. So as state model suggests, the model which is going to provide us that interaction of objects within themselves, but with respect to the time, how the behavior of objects is going to be as and when the time frame. So let me give a small scenario. A state model may be visualized like this. So assume you have a electrical switch for a fan to rotate, let us say. And when fan is in idle state, which is not working right now, so that is being controlled by the switch, because switch is off. So each state of any system, in our case it is a fan, let us say, is going to be monitored by the activity or the event called as a switch. So when I switch on, when I press the button, when I press the switch, which is in the on mode, so I mean I'm moving from off mode to the on mode. That is called as an event. So an event is occurring, or event is influencing the state of the fan to change. So far the fan is in a off mode, meaning that it is not rotating. The minute I switch on, when I provide the power supply to the fan through a event called as a switch on, the fan starts rotating. So what is happening there? The state of the fan, which was idle or not rotating all this time, now starts rotating. So that means an event is influencing a state to happen. That is one example. Second example, let me take a bank system. A bank today starts at 10 a.m., let us say, with a 10 lakhs rupees as a cash. And suddenly some customer comes and withdraws 5 lakhs rupees. So the state of the bank at 10 o'clock, 10 minutes is 10 lakhs to 5 lakhs. It has changed now. When this bank operation started, it was having 10 lakhs. After maybe 10 minutes, once customer withdrew money, which is 5 lakhs, the state of affairs in the bank at 10:10 is not 10 lakhs, it is 5 lakhs. Why? Because an event occurred. What is the event? A customer came and withdrew some good amount of time. As a result, the state of the bank has changed. Or after half an hour, another customer comes, deposits 1 lakh. So because of the deposit of 1 lakh into the bank, which is an event here, the state of bank treasury or the state of affairs of the bank has changed or moved from 5 lakhs to 6 lakhs. So states are happening because of some dynamic activities, maybe within the system or outside the system. What is within the system? Inside the bank in this case, or outside the system, what is happening outside the bank? They also might influence how the operation. That is something different from the modeling perspective, but let us not get into those finer details. But what we have to see is a state is going to change with respect to the time, and state is going to be unique at a given point of time. So you cannot have multiple states. A state can be unique, and it should be unique rather. You cannot have 6 lakhs at the same time 7 lakhs, not possible in a bank. At the same time, you cannot have a fan rotating and fan is not rotating, not possible. At any given point of time, state of an object is unique, is single only. It cannot be multiple in nature, right? That is what practically we see. So this is just a background how a state can be visualized or looked from a object perspective or from a class perspective. So let me present a PPT on how state model can be portrayed. Hope the screen is visible.
Yes, sir.
Yeah. So this is what the syllabus, what we'll be looking in module 4, majorly talks about the state modeling and its advanced state modeling concepts. And we conclude this model with a interaction model as well. Okay. So let us get into the state modeling. So when it comes to the definition perspective, a state model is going to portray the various operations within the object, but that occur with respect to a time frame at a given point of time or based on some activity that is happening. So there is a triggering material for a state to happen. States cannot happen on their own. So there should be something. The triggering is nothing but an event. So states and events are hand in hand. So unless events are there, you cannot get a state. Or unless the events occur, states cannot, the state of an object cannot change from one state to another. So as a result of a occurrence of a event, a state of a particular project or a particular event or a particular object is going to take different shape or move from one place to another place or move from one state of affairs to another state of affairs. So event and state are two integral parts as far as the state modeling is concerned. And the state diagram is a majorly to associate with the objects rather than the classes. What you have seen in the class diagram or class model is completely the classes, the generic classes. But when it comes to the state cannot happen to an abstract data. It should be a specific data. So obviously, it should be related to the objects. The objects and links that we have in a particular class model or object model, they are the inputs for the state model to be visualized or state model to be built. So state model is a replication of the objects that we have already seen in the class model, and what type of changes that come in or that are brought into the state as a result of some occurrence of an event is going to be portrayed or visualized through a state model. So it is a sequence of operations that happen inside the object because of some activity, because of some event that occur over a period of time. So when it comes to the building blocks of a state diagram, we have an event. So event occurs as per the time. So it is based on a time schedule. And states, of course, as a result of an event occurrence, state of a object changes. Okay, that is how these states are there in the state diagram. Then we have a transition. For example, if you take a fan, we have a event which is a off. That means fan is off, switch off. Then later you move to the concept called as a switch on. When I make switch off and switch on, in between these two, some transition happens. What is this transition? The fan is running, the fan is moving, the fan is rotating. So transition happens from one event to another event, or one state to another state. So as a result of an event, some happening that is there in the object is nothing but a transition, and we can also say them as an action. So because of some activity, some action is being happening. So transition is the way the data or the input are moving from one state to another state, and this transition is happening because of an event. An event was triggered, and when event triggers, the another event which is associated will also be there. For example, switch on, switch off for a fan. If that is the case, event is a switch off and event is a switch on. In between these two events, there is a state. What is the state? The fan is rotating. What is the action taking place here? As a result of this transition, fan is rotating. So action part is nothing but rotation. So majorly we have to concentrate on events, states, and each state can move from one state to the another state through a concept called as a transition. And this transition are result of an action or the events that occur on the either ends of the state. Okay, so these are the main inputs or building blocks, rather we can say, as far as the state diagram is concerned: events, states, transitions, and actions, right? Yes. Now important is event. So normally in the exam they will ask you, what is an event? What are the different kinds of events that are existing in the state model? So there are three kinds of events. We'll see one by one. So first let us see what is an event. So an event is a occurrence at a given point of time. So event happens, switch on. Today at 12 o'clock, I'm going to switch on the fan. So it is happening because there is a occurrence at a given point in time. So because state model is completely based on the time, the duration at which the state of affairs are changing, and it happens through a concept called as a event occurrence or event triggering. So that event triggers because there is a need for that event. So an event rather is an occurrence. It has to occur, it has to take place at a given point of time, right? So you can press a button, you can start reading a book, you initiate a motor switching on, you stop the motor, you ignite the car. All those things are results of events, right? So an event is like that, is a occurrence at a given point in time. You can have any example. The starting of a class, ending of a class is an event. Starting of a motor vehicle and ending of a motor vehicle is an event. Takeoff and landing is an event. I mean, event to event. Between takeoff and landing, there is a state. What is the state? The aeroplane is flying. Flying is a state. So the state is always a verb. That is way how you can identify the states of a particular. A fan is rotating. So rotating is a verb. So rotation is going to be a state of affairs. Okay, so that's how we can figure out as well in the given text. So there are three different events what you can identify or categorize. This is what I was talking about. If you assume that straight line is a state of affairs, when you switch on something, what will happen? When you switch off something, what is going to happen? So between these two, switch on, switch off, turned on, turned off, we see an activity. Here it is generally it is portrayed powering off, no powering off. If it is a power, that is a state. A particular motor is supplied with the power between the switch on and switch off. Once you switch off, no power until you switch on further. So therefore, it is not powered between a switch off and switch on. So this is how the event. So power turned on, power turned off is an event. Between two events, what is occurred here is a state. So as a result of turned on of a switch, a particular motor is powered and it is rotating. Maybe a fan or maybe a machine or maybe a motor or anything. So this is how we can visualize. Between two events, something happens that is nothing but a state. Okay. And each state is a finite. it is based on the two events. One is the occurrence of a one event. Second one is occurrence of another event. Between these two, whatever comes is a state, and it is going to be finite in nature, maybe to some extent time bound as well. And we know that state model itself is completely based on a time. It cannot be infinite, right? Yes. So types of events. Okay. So as I said, an event is an occurrence of a particular activity in a given point of time. And there exist three kinds of events. One is a signal event, time event, change event. I would like to recall some of the concepts of computer organization at this perspective. Probably some of you would have understood when you studied at BCA. Recently also we had as a bridge course for some of the students where there was a concept of a computer organization. There you might have come across as a condition code register or a status code register or maybe a register which keeps track of as a flag register, right? So what is the signal here? Signal is, or you can visualize your traffic signal rather. So signal event occurring based on certain activity or occurrence. So if you take an automated traffic signal, what will happen? The signal will be red or green or yellow based on the movement of vehicles. If more vehicles are coming, that particular direction will be green for more time. If vehicles are not seen, then probably that traffic signal might turn to yellow or red. So that might rotate in the entire circle where the traffic signal is being monitored. Or you're doing some computation where you are telling A plus B is equal to C, and you want to check whether C is a positive or negative. You're checking a signal there. If C is positive, do some activity. If C is not positive, do something else in your if-else statement, right? You keep doing that many times. So there is a signal. If C is positive, as a result of that activity, as a result of that event, you take some activity. What is that? Printf, else scanf, let us say. If that is the case, based on that event, you are having, that is a concept of a signal. So signal events are very dynamic in the nature, and they occur as a result of some activity like we have taken just now, signal events. Second one is a time event. Okay, so the time event, so this is a signal event. So it is a, majorly it is one-sided. I don't know if you remember that flag register. Whenever a data changes from positive to negative or negative to positive, it sends a signal. You might have heard about a hardware signal, software signal, interrupts. They're all nothing but signal events. Majorly, a signal is transferred from one place to another place. It is up to the recipient whether to take action or that. It wants, it may take. If it doesn't, it might have. You might have seen in networks as well. All signals are generated, and the signals might be honored, or the signals can be considered for doing some activity, or signal can be ignored. Majorly, surprisingly, all signals are ignored. That is a default action that you can see in networking, right? That means signals are majorly as a signals. For example, tomorrow there is going to be rain. That is a signal from meteorological department. Or tomorrow there will be a flood. That is a signal. Tomorrow there might be some tsunami. That is a signal. Tomorrow there might be visit of something. Signal. So it is up to us, who are the recipients, to make sure that, oh, if it is going to rain tomorrow, let me get ready with umbrella. Just because you don't have umbrella, signal is not going to stop, right? Signal will be given. So signals are majorly, in practical, they're one-sided. They're one-way data. The recipient should act accordingly in the best interest of the system. So that is the concept of signal that is there in every computer and even your day-to-day life, where signals are signals. They keep giving certain info. Even if your traffic signal, when red is given, you should stop. But many times people still traveling. So what is happening? Later you will pay some fine and something will happen. So like that, signals are majorly one way. It is up to the recipient to take a call and ensure that the signals are honored. If you do not care for the signals, finally we end up doing some wrong things, so which is not good for us. When it is given a signal that you should not go, red signal is given, you should not. If you go, what will happen? Maybe you are caught by the traffic police, or you have to end up in paying some fine. Or if the signal is there, tomorrow it is going to rain, if you do not take enough safe or care, probably you are going to get disturbed by the rain, or you are going to put yourself into trouble. All those things. That means signals need to be taken from the spirit that how to act for them. You cannot ignore always, right? So this is how it is going to be. A signal is a signal, and that is majorly a one-way transmission of data moving from one object to another. They happen over a given specific period of time, because basically all events are time bound, and that is how it is going to happen as a result of some internal activity, right? So that's how signal event is. Next, time event. So time, as the name says, time, it happens at a given particular time. For example, your alarm is there. You say morning 5 o'clock, the alarm should ring. So you are kept at when my alarm is 6 or 5 o'clock in the morning, you should wake up and you should give me a sound that so that I can get up. So that is an example of a time event. Or you might have seen in Unix, scheduling of processes at batch, cron, we have seen, they're all time events where they say that at given point of time, this activity should happen. This process should get executed. They are the examples of a time event, which are time related, meaning that when you specify this particular time, during that time only they keep happening. So when the time reaches this particular date, or when some time elapses like an alarm. So all these things you can be part of the time event. So when a particular date of birth is there, you want to wish someone, so it is a time event, because you will wait for that date to come. That is an example of a time event. So when your date is equal to this, or when a time is after 10 minutes or 10 seconds or after 10 hours. So that is how the time events. Best example may be your alarm clock, or maybe you want to wish someone on a birthday or some occasion. So these are all the examples of events which take place at a given time frame. No doubt all these events are time bound, but when they occur, as a result of what they are going to occur is what is going to decide whether it is a signal event, whether it is a time event, or whether it is a change event. Another one is a change event. So change event means like your traffic. So after every 10 seconds, the traffic is going to change, or it is going to affect based on some internal changes, right? If that is the case, we call it as a change event. So they're all look interrelated, but they have a specifics internally. And when you might have seen inode, I don't know how many of you still remember, in Unix we have discussed about a inode number, which is one of the characteristic or a property of a file. Inode number change is there, meaning that when someone deletes a file, when someone updates a file, only contents will update. Inode will never change, because inode is a unique number. So some change event, something is changing, modification time is changing, so it is getting reflected within the inode. Inode contains a lot of information, so modification time of a file is one of the change. Since it is changing, the change is going to take place in the modification time. Similarly, access time, when you access the file, the change event is going to happen, and accordingly the file access time has changed. So file deletion time, so all those things are going to be change events. When something is happening, as a result of that event is happening, no doubt, and in this case it is a change event. So these are all the events. One is a signal event, based on some activity, something is happening. Time event, when some time is met, we are going to have this event happening or occurring. Change event, when something is allowed to happen. For example, in the example you have taken here, battery power, you have set in your system that when you charge the battery, you are going to get an alarm, you are going to get a signal, you are going to get an event happening that when your battery is less than 25%, you have to go for a charging. So that is an example of a change event. Something is changing. What is changing? Your battery power is coming down. There is a change. It has moved from 26 to 25%. Now we are getting a event occurring. As a result, we call it as a change event. So, or you want to switch on an automatic pump at your sump for water uploading. So probably what will happen, once some threshold value is reached, that means after some time you have to, what to say, switch on the motor and pump water to your overhead tank, then probably after some time that is to take place. Or if you have a vending machine, hope you are all aware of vending machine, because nowadays they are not seen, but vending machines are always available in a major crowded places where human interaction is not available, or not possible rather, where you put a 5 rupee coin and you will get one biscuit packet, let us say. So that is a vending machine. or you give 10 rupees, you'll get one Coca-Cola. So they are the vending. That means some specific event. So as a result of you providing 5 rupees, you are getting some output. So the question here is, what is a change event? So change event occurs in a vending machine when out of 100 Coca-Cola, 80 are sold. I'm left with only 20. So before this 20 are sold again, I should make sure that the vending machine is equipped with the remaining 80. So I cannot wait until the Coca-Cola is zero. Then the customer comes, he or she finds there is no Coca-Cola, right? I should pump the Coca-Cola as much as possible required to meet the demand of a customer in a given place. So I need to look at when my inventory comes below a particular threshold. Let us say when number of Coca-Cola reduces from 100 to 20, then I have to reorder. That is an example of a change event. Or you can take your recent advertisement of a refrigerator, where you are all hearing that artificial intelligence is coming and making a lot of buzz and noise in the market. One of the example of Samsung, I believe, they have shown 5-in-1 or something, where you need not do anything. You can keep 2 kg of apple in the container, keep on eating. The minute it becomes 1 kg, the entire Samsung system, which is a refrigerator today, will order maybe from big basket. Look, my apples have come down from 2 kg to 1 kg. Get me 1 kg today, end of the day. So what is happening there? Change event. That means when some threshold value is met, you are taking some activity to happen. You are triggering some event to happen. That is an example of a change event. So these are the 3 events. Hope you have got the clarity. What is a signal event? What is a time event? And what is the change event? So let me take a pause here. Let me know if all could understand what is a state model and what do you mean by a state and how these events can be phased out. If you have any doubts, you can let me know. Any doubts?
No, sir.
Okay, fine. Now let me get into the states. So we know that as a result of occurrence of an event, a state is going to come into the picture. A state will be existing until another event which is associated will happen. Like your fan, a switch on is an event. Once you switch on, the fan starts rotating. So rotating is the state of the fan. How long it will rotate? Until another event comes. What is that event? Switch off. If you do not switch off, fan will be keep on rotating until it fails to rotate because of some mechanical issue. We're not going to that level today. We are worried about an event. So an event should happen. What is the event? Some occurrence. So that occurrence is nothing but a triggering point for a state to begin or state to end. So that is the concept of a state. Our interest here is not this concept, but how we can represent them in the UML. So in UML, we represent this with a particular notation. Hope you understood the class model. Class is nothing but a rectangle box, right? A rectangle box which can have 3 compartments. In the first rectangle box, it is the name of the class. Second rectangle box, it is the data members. Third rectangle box, it is the functions that we have, whom we call it as a methods, right? So this is how we are going to have as far as the class diagram is concerned. Now what we are looking at is a state diagram. So how a state diagram looks like? A state diagram is a similar rectangle box, but you can see there is a curve in the edges, a round box you can say. It is also like rectangle box, but the difference is the flat edges are not here, but there are curved edges. If we have this particular one, it is nothing but a state. So a class is a different model and state is a different model, but how to identify in UML? Same rectangle box, but if it is a flat corner, it is a class. If it is a rounded corner, it is a state. Here also it is possible to have 3 compartments. One is the name of the state and some variables that are there as a part of it. That means which are triggering, what is influencing. For example, the state of a bank, the cash, 10 lakhs. The number of people working in the bank, 3. Number of customers, 5. These are the variables. Okay. Or when it is raining, what is the type of rain? and how many millimeter or centimeter rain is coming, which location it is coming, what is the duration, how long it is coming. All those things are going to be variables. Action as a result of what the state is occurring, or since this is a state, what is happening? Fan is rotating, fan is not rotating, fan is rotating with the speed 5. So this is how the action is. So state also will have a 3 compartment. One is the name of the state, variables that are influencing the state to happen, and action which are coming as a result of the state occurrence. They are going to be part of, but nevertheless what we have to visualize is the difference between a class model and a state model. So class model, class is not defined or designed such that it is a rectangle box with a flat corners, whereas in UML the state model is depicted as a rectangle box again, but not with the flat, but is a curved corners. So that is the difference what you have to keep in mind, because more or less both look like, so you should not get confused. So flat as well as the rounded corners is what is going to differentiate which is a class or a state. Okay. Now, as I said, so you have one state. You are moving from one state to another state, because if a fan is running, it cannot be running always. It has to move from not running or not rotating state, or it should go to not movable. So if that is the case, a state transitions from one state to another state. So that is nothing but a transition. So state, which event is triggering the state to transition from the present state to the next state. And there are some conditions, guard condition. What do you mean by a guard condition? So for example, if you take a traffic signal again, you say that from red to green or green to yellow, there should be some time frame. One is, no doubt, you are having a automated traffic. That means if more vehicles are coming, allow them to go. Or if less vehicles are coming, give them a less period. But one more condition I can bring, which is going to govern above this. What is that? No doubt, when vehicles are not there, I should stop for a red signal. How long? Suppose there is a road which is always busy. Vehicles will keep coming without any gap. If that is the case, if you go for an automated traffic signal, only that road will be freed. The adjoining roads will be always bottlenecks, because they will not be able to get into the mainstream. So you should always come with a condition. No doubt, even though we say when vehicles are not there, you should stop, or when vehicles are moving, you should allow them, but there should be some condition. Maybe 10 minutes, sorry, maybe 10 seconds, or 15 seconds, or 20 seconds. So one more condition I'm bringing, that is nothing but a guard condition. So based on what type of data, or based on what type of condition, you need to take this event to the next level. So if that is the case, a guard condition also will be there. Then we have a final state. So source state, target state, that is moving, not moving, happening, not happening, rotating, not rotating. So this will happen through a system of events, starting event and ending event. And if required, we can put the guard condition. Guard condition is an optional, may be there, may not be there. But what is important is source state, target state, in between they happen through a result of an event. So between the source state and the target state, what you see, the transition is nothing but a line, like we have seen in a class diagram, an association. A line between two classes is nothing but transition in the state model as well. So let us look at this. So this is how the UML syntax for a given transaction. There you have seen a simple line without any arrow marks, because that was a bi-directional. But here there is an arrow. Why? Because you are telling that from source to destination, it is not reverse. From destination to source is not happening. You are moving from one state to another state. It is a one directional. Thereby, you are giving an arrow, which is a pointing towards the target state from the source state. So you should be very wary about these lines as well. Lines without any arrow marks is a bidirectional. Lines with arrow marks can be unidirectional, depending upon where or how they have been used in the diagram. So that's what the concept is. These are the two states now. There is a state by name idle. Now I am moving to idle state to running state. When I move from this idle to running, I cannot jump. There should be some possibility, or that is something is triggering the triggering is nothing but a state. So how do you represent? You represent with a line. So here it is running state to idle state. We have represented. So which is the starting state here? Running becomes the starting state, which is the target state. Idle becomes the target state. So that's how you need to understand. So one state to another state we are moving as a result of some action and some transition. The transition is nothing but the event. Because of some God condition, because of some event occurring, we are moving from one state to another state. So another case is from idle to running, I am moving. So which is the source state here? Idle is the source state, running is going to be target state, right? So because arrow mark is from idle to running. So it depends how we have written the arrow. So which is pointing towards the state is going to be the right hand one, and that right hand one is going to be your target state. So if the pointer is towards a particular state, that particular state is going to be considered as a target state. The origination, the starting state is obviously is a source state that is going to move from one place to another, or one state to another rather. That arrow is nothing but a transition. It is happening because of some action, or because of some condition, or because of some activity or event being triggered. Okay, maybe switch on, switch off. Okay, so that is the transition we are talking about. Okay, so these both are the transitions here, right? Yes, this is another example. So we have an unpaid. So can you see the difference in the boxes? They're all rounded boxes. So it is not a class now. It is a state. So unpaid state to paid state I'm moving. Why? Because I'm paying. So paying is triggering. Paying is an event here now. Since I am paying, I paid, I'm moving from unpaid state to paid state. Okay.
Excuse me, sir.
Yes.
Sir, in the running and idle state, sir, in running and idle state, when sir we are showing the transition from idle to running or running to idle, so can we give it as a bidirectional arrow?
You can, but how do you visualize?
Sir, because we can switch from idle to running and running to idle.
That's true, but see, as I said, they're all time bound. They're not happening always, right?
Yes, sir.
Running to idle happens because of some event.
Yes, sir.
And maybe as you progress further, you will see within running we write something. What is that? Because of what it is, why it is happening. If you put it bidirectional, there are chances that you may get confused. What is triggering this event to happen? What is responsible for this state to happen?
Yes, sir.
This diagram is shown just to give an idea which is a starting state, or which is the ending state, or which is a source state, or which is a target state.
Yes, sir.
Not to write bidirectional, definitely no.
Yes, sir.
Because they happen at a totally different time frames. They are independent each other.
Yes, sir.
So you cannot write. Better to avoid bidirectional. I think it should not be.
Okay, sir.
Yes. And every time you will not get bidirectional. This is just example. You move forward. The propagation is from left to right many times. Once you move from idle to running, you may go further. You may not come back every time. Right?
Yes, sir.
So better to avoid the bidirectional for states. I mean transitions. So now look at this, unpaid to paid. Can you come back to unpaid?
No, sir.
May not be possible. Maybe if you take a refund, that is secondary, but 99% it is a forward. Then you have to pay it to refund. You have to go. You will not come back. So that's why state diagrams will always have a unidirectional. Okay. Yeah. And action, of course, you know how the action things are happening. So this is what I was talking about. Internally, you can say because of what it is happening, because of something it is happening, because of some activity it is happening, this we can do. So within a state, we can specifically write whether it is an entry, whether it is an exit. When I say entry and exit, it cannot be bidirectional. It is only one-sided, right? or when I say because of this, this is happening, this state is occurring because of this, you can write some more clarity. So this is how we can write them. So you can see now, in unpaid to paid, how are you moving? The starting state, and what is the ending state? Okay, so from invoice to unpaid, unpaid to paying, paying to paid, and finally amount has been taken into consideration. This is how we move from one direction to another. Okay, these are all examples, but let us take this example now. So you can see within the class, we know that there are three compartments. Sorry, within the state, there are three compartments. One is the name of the state, variables that are going to influence the state to happen, and the actions that are going to happen. So below that state, you can see in the first one, setup is there. Below that, you see some do. Available is there, do. So do represents an activity, whereas entry and exit will talk about a normal type of events that are going to happen, right? So that's how we should be looking. Available is happening as a do action. What is the internal action? Setup means what? Initialize the seminar. Available means what? A speaker is available to speak in a seminar. So like that, we have a what to say, internal representative. For example, if you take a cancelled as a one of the state, so what is below that? It is written state is a cancelled state, but what should I do now? So you should give the money back to the participants because your event got cancelled. So just because by writing cancelled, we're not stopping there. We're telling what is the next action, what we have to do. So a state, if you want to associate with action, we can write further. But everywhere you see, everything is a unidirectional. There is no bidirectional here, right? So that's how the states will move from one place to another. So let me take another example. So I don't know how many can visualize this. This is about the washing machine. So washing machine, it is ideal state. You start putting clothes into that and you switch on and washing take place. And the before actual washing, the whatever the powder we have given, it will be initially 10-15 minutes. It will rinse the entire cloth and later it will wash and finally it will go to the dryer where you will be drying the clothes. These are all the process here. So that is a state. One place to another place it is going. So how this happens is a state of affairs, moving from one state to another state. At the end, you are done with the clothes being washed or whatever it is. So this is how the states. But here the diagram is confusing because they have written as a what you call flow chart. But if you look at the left side, the states where you can see a UML model for this. So you have a flow chart and we're converting that flow chart into a particular state diagram. If that is the case, you can clearly see that the state representation is in the rounded corners, not rectangle. This is just an identification and we're converting them into states. So washing is a state, idle is a state, rinsing is a state, dryer is a state. What are the transitions? The movement from one state to another state, they are going to be the transitions. Okay. So this is how we can write a particular flow chart and activity in terms of a state diagram as well. That this is example what we have. Probably this might be another example I can take. So this is what traffic lights you all see. See, this is how the transition. Everywhere you see there is a one directional, right? So let me take a more visualized one. Yeah, probably this is the one what we have in the exam. You may get in the exam as well. Write a state diagram for a phone line. So keep visualizing this, understanding. Let me take attendance. Meanwhile, I'll come back. So let me know how you visualize and understand this from a state diagram perspective. So I will come back in 5 minutes post the attendance. So meanwhile, let me take attendance. Number 1. Number 2.
Yes, sir.
2, 3, 4,
Yes,
6,
sir.
Yes, sir.
7, 8, 9,
Present, sir.
10, 11,
Yes, sir.
12, 13,
Present, sir.
14,
Present, sir.
15,
Yes, sir.
16, 17,
Sir, 16 present.
17, 18,
Present, sir.
19,
Present, sir.
20, 21,
Present, sir.
22,
Sir. Present, sir.
23,
Present, sir.
24,
Yes, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present, sir.
29, 30,
Yes, sir.
31,
Yes, sir.
32,
Present, sir.
33, 34,
Present, sir.
35, 36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39, 40,
Yes, sir.
41, 42, 43,
Present, sir.
Present, sir.
44,
Present, sir.
45, 46, 47, 48, 49,
Present, sir.
50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53,
Present, sir.
54,
Present, sir.
55, 56,
Present, sir.
57,
Present, sir.
58,
Present, sir.
59,
Present, sir.
yes. If you look at this, this is an example of a state diagram, right? So phone line, if you remember, or if you observe rather, how is that line written? It is written like a pentagon, right? There are 5 sides. So name of the state diagram is written in the left top corner with a pentagon shape. If that is the case, what you can say, that is the name of the state diagram.
For present.
What is the name of the state diagram? Phone line. The name of the state diagram here is a phone line. So it is always written on the left top corner with pentagon shape. Second, how many states are there? You know how to write the states, right? State is a rectangle box with a curved edges. So idle, dial tone, timeout, warning, dialing, recorded message, connecting, ringing, connected, disconnected, busy tone, fast busy tone. There are 12 states in this. Blindly, how can you say? One is a verb. Every name of the state here is a verb. Second way is, how are they put in? They have been represented within a rectangle box with a curved edges. If that is the case, we can say it is a state. There are 12 states here. And we also see transition moving from idle to dial tone to dialing, dial tone to warning, dialing to warning, warning to timeout, and all you see they're all single directional. They're all unidirectional, right? So because we are moving from one state to another state. So this picturizes how a phone connection happens. Probably you can imagine your what you call old analog phones. Your system will be idle. You pick the what you call the handle. When you pick the handle, we call it as a half hook. Half hook means you're removing the handle from the mic, your mobile, your phone set. We call it as a event. As a result of event, what is happening? Dial tone comes. So dial tone is a state. So once you get a dial tone, you start dialing. How do you dial now? You have the keyboard, you start typing the numbers. So suppose what will happen if you don't type for some time, timeout, it will give a warning, beep, beep sound. Then it will go to the timeout, it will go to the idle state, meaning that you have to replace back your handle. Assume you have done perfectly, you have typed the digits. You might have typed some wrong digits. Again, you'll go back and you will type. So you are still in the dialing state only. So that is a self loop. If you see dialing, there is a digit which is a self loop. You are in the same dialing state only. Then it will say, if you have pressed some invalid number, it says the number is not existing and something will come. Some message will come. After that, again, you go back to the idle state and start the procedure. Suppose dialing is correct, you have given a proper number, valid number, then you'll go to the connecting. This is how you can look at what you see in a daily life, how a phone works. You're all aware of that. Entire thing is picturized here. So that is nothing but a phone line state diagram. So every state, you can visualize now clearly how things move. Every minute details have been considered here, and we have written the state diagram. If this is given tomorrow to a developer to prepare a software package for it, he or she will get a complete knowledge how this can be routed through or how this can be considered. So this is how the picturization is going to give you a details about that. So any doubts here on the state diagram? Yes.
Sir, on hook and off hook, what is this, sir?
Pardon?
On hook and off hook.
See, half hook means, I don't know, you might have seen your old phones, right?
Yes, sir.
Where you have a handle, cable will be there. You remove the handle from a phone. You have to speak, no?
Yes, sir.
That you have to remove from. That is a half hook. Hook means you are removing it from a system. You are, what is it called? Taking out from the phone system. That is a half hook. On hook means you keep it in normal place. You put it back to the system. After you speak, what will you do? You'll put the handle back to the phone, right?
Yes, sir.
That is on hook. You are keeping back to the normal. Off hook means you're removing it out.
Okay, sir.
To speak from a phone, you have to take that mic, no? I mean that entire handle of a phone.
Yes, sir.
That is a half hook. So probably what we can do here is consider a bank ATM, right from insertion of a card until you take the card out. Whatever your perception about a bank ATM, write a state diagram like this. So develop a state diagram for bank ATM. You take your own bank where you transact on a daily basis. Whatever you experience, try to write in the similar lines. So if you develop that, probably you'll get an idea how ATM works and how a state diagram can be written for a ATM system. So that you can take it as a homework. Try to do that ATM diagram for a state model. Okay. So with this, probably I conclude today's discussion. We'll move to the next in the next class. If you have any doubts, you can let me know. Yeah.
Sir, after from the present, sir, mic issue, sir, on that time. Camera is on, sir.
Okay. Okay.
Thank you, sir.
Yes. Done. Yeah, if you don't have any doubts, I shall stop.